So we're going to go over 2.7, which is solving proportions. Now, these are the first 7 problems to kind of warm you up, as to remind you multiplication and division. So let's go over them. So for the first one, we have 6x is equal to 36. The way you get rid of that 6 to get the x alone is dividing by 6 on both sides. And we're left with x is equal to 6 because 36 divided by 6 is 6. For the second one, in order for us to get rid of that 4 to get the x to be alone, we are going to multiply times 4 on both sides. I'm just going to leave us with x is equal to 12 times 4, which is multiplied out right here on the side. 4 times 2 is 8. 4 times 1 is 4. So we're going to be left with x is equal to 48. Now for the third one, again, we want the m to be left alone. So we're going to divide both sides by 5. And we're going to be left with m is equal to 18 over 5. Now, you don't have to simplify it and give me a decimal because I will accept a fraction. I actually prefer you guys leaving a fraction as your answer. So that is plenty. 18 over 5 would be perfect for your answer. For number 4, again, I'm going to multiply that 21 out on both sides, which is going to leave us with r is equal to negative 3 times 21. Again, I'm going to go solve it over here, which is 63. Now, it's negative 63, just as a reminder, a negative times a positive is a negative. So that's why it's a negative 63. For number 5, I'm going to divide by 8 on both sides, and it's going to give me y is equal to 18.4 over 8. You guys can simplify this by 2, so I'm going to divide the top by 2 and the bottom by 2. I'm just going to write it out. So it's 9.2 over 4. I can actually simplify by 2 again. And then 9.2 divided by 2. We get 4.6 over 2. You can actually simplify it one more time. I'm going to actually delete my side work right here, so I can do it one more time. 4.6 divided by 2. Bring down the 6. We get 2.3 over 1, which is just 2.3. So you see, by simplifying it slowly, we realize that it was a decimal on the top over a 1. You could have tried to do 18.4 divided by 8, but it just seems like a lot at the time. So we just went one step at a time, and we still got the same thing. Now, for number 6, I'm going to put this as an over 1 in order to be able to multiply it. So I'm going to get 8 times 7. 56 over 8, and again that simplifies to 7 over 1, which is just 7. And then I'm going to erase the work, all of this extra work, just for the final answer, so I have a little bit more space. Now for number 7, again, we're going to put it over 1. 12 times 5 is 60. And then 6 times 1 is 6. That simplifies to 10. Any questions? So now, after we did the warm-up, let's start with 2.7, solving proportions. Our objective today is to write and use ratios, rates, and unit rates, and to write and solve proportions. Now, a ratio is a comparison of two quantities by division. The ratio of A to B can be written as A two dots B. Can be written as A over B, but the B cannot equal 0. ratios that name the same. So the two dots and the fraction, it's the same thing, guys. It's just written differently. So comparisons are said to be equivalent. So a statement that two ratios are equivalent, such as 1 over 12 equals 2 over 24, is called a proportion. Now, so you guys understand what's going on here. We have 1 over 12. If I multiply that 1 over 12 times 2, that's where the 2 over 24 comes from. Again, we can do the same thing if we multiply it times 3. So for example, 1 times 3 is 3, and 12 times 3 is 36. That is also an equivalent proportion, guys. It's always a multiplication of the numbers or a division of the numbers. You can say both 3 divided by 3 is 1 and 36 divided by 3 is 12. So you can go either multiply on the left in this case to increase it, or divide from the right in this case to simplify. But that's what a proportion is. It's equal to each other in a larger or smaller quantity. So reading math here is, we would read from top to bottom on the left fraction to the right fraction. So we would read it as 1 is to 15 and as x is to 675. You guys remember, we're not going to solve it like 100%. I'm just going to start it off. Do you guys remember how we did the butterfly like this and like this to get common denominators when it came to fractions? Well, if you don't remember, it's okay. We're still going to multiply across. So if we multiply the red with the red and the blue with the blue, that will always be the case. We will never change that. We will be able to solve this. So if we do 15 times x, it's just 15x. The equal sign remains there. And then we do 675 times 1, which is just 675. We cross multiply, and we're able to get this equation, and then you guys are able to solve this equation by division. We're not going to solve it right now. I just want to get you guys in that mindset that that's how you solve it. Makes it easier if you just start seeing it from now. So in a proportion, A is to B as C is to D, the products A and D and B or C are called cross products. So what we did before, guys, A and D and C and B are called cross products. You can solve a proportion for a missing value by using the cross product property. So what we just did the last slide. You guys notice in the chart at the bottom, we have the words in a proportion cross products are equal. So you guys see the red and the green? They did 2 times 6 is equal to 3 times 4, which is the case. They're both 12. So you know that is a good proportion. And that's how it works. Now, if B is equal to 0, that cannot be a proportion. Keep in mind, a fraction with a 0 at the denominator is not a good fraction. We went over this, is undefined. So if you have an undefined fraction, guys, that is not okay. The ratio of the number of bones in a human's ears to the number of bones in the skull is 3 to 11. There are 22 bones in the skull. How many bones are in the ears? So this seems like a lot, but let's break it down. They're telling us in order that it's number of bones in a human's ear to number of bones in the skull. So that means, actually let me change the colors. So that means that the ear is 3 and the skull is 11, right? And they're telling us there's 22 bones in the skull. So this is the other part of the proportion in red. Guys, it is really important that you're consistent with your proportions. So if I'm going to write 3 over 11 equals, and I'm trying to figure out how many are in the ear, I'm going to write an X for the ears over 22. So keep in mind how I kept the skulls, both of them on the bottom, and the ears, both of them on the top. That is really, really, really important that you're consistent on how you write the proportions. If you're not consistent, it will be wrong, and you guys will get marked the wrong answer. Now let's solve it. We're going to multiply the 3 and the 22, and the 11 with the x. Now, 11 times x is just 11x. I'm going to write it in. And 22 times 3 is equal to 66. So then I will divide both sides by 11, and I'm going to get x is equal to 6. So there are, according to this problem, there are 6 bones in the ears, and there are 22 bones in the skull. And it's a 3:11 ratio, so we figure it out, and it's good to go. So, all right, so the ratio of games won to the ratios of games lost for a baseball team is 3-2. So let's figure out. They said 1 first, so they put the 3 first. They said lost second, so the 2 is a second. It's 3-2. So the team has won 18 games. So again, 1 is blue. How many games did the team lose? So let's set this up so we can solve it. Let's do it again with colors. It's going to help you. So we have 3 won over 2 lost. And we have 18 won. And we're trying to figure out how many they lost. Now that will be red because it's lost with the red. I just didn't change the color. Again, we are going to cross multiply. Cross multiply. We get 3 times x is 3x. And then 18 times 2 is 36. Then I'm going to go ahead and divide by 3 on both sides. And I get x is equal to 12. Alright guys, let's do A. So we're going to multiply 9 and the 5 and then 3 and the m. 3 times n is 3m. And then 9 times 5 is 45. Afterwards, to solve for that m, I'm going to divide both sides by 3. You get m is equal to 15. Again, for b, it's the same thing. We're going to do 2 times y minus 3 and then 7 times 6. Now, for the blue one, which it has 2 terms, I'm going to actually write it as 2 times y minus 3. If you guys notice, I wrote it that way because we have to multiply the whole term. And it's just going to end up being a distribution at the end. But it's just good to write it that way to get used to it. And then 7 times 6 is 42. Afterwards, I'm going to distribute that 2. Again, guys, please remember it's to both terms. So we get 2 times y is 2y minus 2 times 3 is 6 is equal to 42. Then I go ahead and I add that 6 on both sides. I get 2y is equal to 48. I will divide both sides by 2. And I get that y is equal to 24. Alright, so to solve for A, again, y times 2 and 5 times 8. So I'm going to do 2 times y is just 2y equals 8 times negative 5 is negative 40. I will divide both sides by 2, and I am left with y is equal to negative 20. Now for the second one, again, we're going to multiply the 7 and the 5, and the 4 times g plus 3. So let's start with the green one. G plus 3 times 4 is going to be written as 4 times g plus 3 is equal to 7 times 5 is 35. Again, I'm going to distribute that 4 into both terms in order to solve for it. 4 times g is 4g plus 4 times 3 is 12 equals to 35. I'm going to go ahead and subtract the 12 on both sides. And let's do this up here. 23. And then I divide by 4. And I get that g is equal to 23 over 4. Again, I will accept and I would prefer you guys leave your answer as a fraction. Now we cannot simplify this anymore. So we're just going to leave it like that. So a scale is a ratio between two sets of measures, such as 1 inch and 5 miles. A scale drawing or scale model uses a scale to represent an object that's smaller or larger than the actual object. A map is an example of a scale drawing. Now, what does this mean? So guys know, let's say you have a map, and let's say you have a building right here, right? And they tell you that this building is 3 inches tall and 7 inches wide. Now that is a representation, because it's of the top of that thing. They're gonna tell you that 1 inch in this case equals 5 miles. So in doing that, we realize that in this drawing is just a scale model. We do 7 times 5, we realize the actual size of the building is 35 miles. That might be a lot actually from what I wrote, but it's fine. And then it would be 15 miles tall. Should probably use a different measure, but like feet, but it's fine. It's just what it is, the scale that they gave us up there. This is just a representation of a scale. So it says a contractor has a blueprint for a house drawn to the scale of 1 inch to 3 feet. One wall of the house will be 12 feet long when it is built. How long is the wall on the blueprint? Now keep in mind, this time they don't tell you win, losses, and all that stuff. All right, so they don't tell you wins or losses. They tell it to you based on units. Inches, feet, and feet. So when I write this down, I'm going to write 1 and then 3. Keep in mind the inches are on the top. So I'm going to put a little bit, I'm going to highlight it green and blue so it reminds you guys of which one's which. The X I'm going to put on the top because they're asking about it on the blueprint. With the blueprints would be the inches. And then the 12 would be down here because it's the 12 feet. So keep in mind how I still kept the units with the same units on the bottom and what we're looking for with the same units that we're looking for at the top. Again, that is the most important part about this. Now I'm going to go ahead and cross multiply the X and the 3 and the 12 and the 1. It's going to give me 3X is equal to 12. Then I'm going to go ahead and divide by 3 on both sides. And I get that X is equal to 4. So on the wall on that blueprint is going to be 4 inches tall. All right, I do want to say you guys have homework and it's due tomorrow.